Hey guys, I hope you all are doing good. In this lecture, we will be covering equivalence relations, equivalence classes, and partitions, right? These are not very tough topics, right? So they're not that important. But since a lot of discrete structure courses cover these topics, we will cover them as well, right? So let's start with understanding what are equivalence relations. A relation on a set is called equivalence relation if it satisfies all of the following properties, right? So if it's reflexive, symmetric, and transitive. So the point is very simple, right? Um, I hope you understand what is reflexive, symmetric, and transitive relationship by now. So if there's a relation R, right? Let's say I have a relation R. Let's say I have the set A, right? 1, 2, 3, and I have any relation on it, right? So let's say 1 comma 1, 2 comma 2, 3 comma 3, right? This is an equivalence relation. Why? It is reflexive, right? Symmetric because if A is related to B, then B is related to A, and it is also symmetric, right? So we can say that this is a equivalence relation in this case, right? So I hope you're able to understand. This is a very basic example. So let's say if you're asked the question to figure out whether a relation is reflexive or not, what you're simply supposed to do is just try to figure out what is the relation and see if it's reflexive, symmetric, and transitive, right? And that's the only thing. Okay, moving on, let's try to understand what is the equivalence class. Given an element A of the set A, the equivalence class of A under the relation R is this condition over here, right? So let's try to understand this condition in detail, what it means, right? Okay, so the basic point is that this is the representation of equivalence class. So for example, let's say this A element is 1 in this case, right? So what we are saying is that X is an element of A such that X is an element of R, right? That relation is an element of the R. So let's try to understand with an example, right? Okay, so let's say I have relation R. Instead of this over here, I have relation R is equal to 1 comma 1, 1 comma 3, 3 comma 1, and 3 comma 3, right? For now, let's assume that there's just two elements in the set, which is 1 and 3. So in this case, the equivalence class of 1, try to figure it out, right? What is the equivalence class of 1 and what is the equivalence class of 3 in this case? So I want you guys to pause this video for like maybe 10, 15 seconds and try to figure this out. Okay, so I hope you were able to figure it out. So the basic point is that this is the class, right? And we are saying that X is an element of A such that A is related to X, right? So let's try to figure out what are the element X's which are related to 1 in this case, right? So there's a 1 and there's a 3, right? And nothing else, right? So we are trying to figure out 1 on the left side and any other element on the right side. So this is going to be a set, right? This is a set and it is going to have the element 1 and 3 in it, right? And same way, let's try to figure out what is the equivalence class of 3 element. So in this case, it is going to be again 1 and 3 in this case as well. So since I know that these sets are same, I can also say that 1 is equal to 3 is equal to 1 comma 3, right? So I hope you were able to understand what is the equivalence class and what is an equivalence relation, right? Not very tough to understand, but there can be some tricky notations. For example, it's very important to remember this notation because it is quite confusing, right? So moving on, let's try to understand what are partitions. Okay, now let's try to understand what is the partition of a relation, right? A partition on a set A is called the collection of non-overlapping non-empty subsets whose union is A. So if R is an equivalence relation on A, the set of equivalence classes forms the partition, right? This probably seems like a difficult definition to understand. So let me just give you an example, right? Let's say I have this set A, right? Let's say A has 5 elements. Let's say 1, 2, 3, 4, 5, right? So I'm just going to represent this in a circle, right? All the elements. So let's say I have 1, 2, 3, 4, 5, and 4 and 5, right? So what is the partition is that basically it is non-overlapping subset, right? What is the meaning of non-overlapping? That there's no element which is common in those subsets, right? So each element is either part of one partition or the other, but they cannot be part of two partitions or more than two partitions at the same time, right? So non-empty subsets whose union is A, union meaning that when we combine all those partitions together, it is going to form this set A, right? So if R is an equivalence relation, right, on A, then the set of equivalence classes forms the partition. So the basic point is that let's say there's some relation defined on it, right? We don't know the relation yet, but based on the relation, there can be equivalence classes formed, right? Partitions formed. So maybe the partition could be this, right? Maybe 1, 2 are part of one partition, 4 is part of another partition, 3, 5 is part of another partition, right? This all depends on the relation that we have, right? Or maybe we can have something like this. Maybe 1, 2, 4 and are part of the same partition, or 3, 5 are part of the same partition, right? Um, how do we know if an element is part of the same partition? It is basically that in the different partitions, right? So let's consider this partition in this case. What's going to happen is that all the elements are going to be related to themselves first. So 1 is related to 1, 2 is related to 2, 4 is related to 4, right? And also each element over here is going to be related to itself, right? So all the other elements as well. So for example, 1 is going to be related to 2, 1 is going to be related to 4, 4 to 2, 4 to 1, and 2 to 4, 4 to 2 as well, right? So all those relations are going to be possible, and that is why they're going to be part of the same partition. Same way, in this case, 3 is going to be related to itself, 5 is going to be related to itself, and they both are going to be related to each other as well, right? So that is why they're going to form a different partitions. But the case is that 3 is not going to be related to 1, and 5 is not going to be related to any of these elements, right? So they're going to form separate unique partitions. So let me give you a basic example of a partition, right? So let A equal 0, I should say 1, 2, 3, 4, 5, and 6, right? So I'm defining the relation based on define A. Okay, so let's try to understand what this means, right? I'm saying that let's say I have this set A, I'm defining a relation on it, R, such that A is related to B, like element A is related to element B, if both A and B are odd or even, right? So for example, let's take a look at it, right? 1 is going to be related to 3, 1 is going to be related to 5, right? 2 is going to be related to 4, 2 is going to be related to 6 as well, right? So first, whenever you're trying to form partitions, the very first thing that you need to do is figure out whether the relation is equivalent or not, right? Which is, it is reflexive, symmetric, and transitive. If it follows all those properties, then only you can go ahead and form partitions, right? So it's very important to note should be equivalence relation. Okay, so now let's try to understand what is going to be the partition, right? Since 1 is related to 3, 1 is related to 5, right? But first, each and every element is going to be related to itself, because both A and B are odd, right? If they are related to each other, then they are both odd or even. So 1 comma 1 is going to be odd, 2 comma 2 is going to be even. So the basic point is that all these elements are going to be related to themselves, right? Second is 1 is going to be related to 3 is going to be related to 1. Same way for 1 and 5, right? And 2, 4, 2 and 6 as well. So if you think about it, the partition, let's say if it's a set P, then the partition would simply be 1 comma 3 comma 5, right, comma 2 comma 4 comma 6, right? So these two are going to be the partitions that I form, right? If you think about it, 1 is related to 3 and 5, right? They're all related to each other. And in this case, all these three elements are related to each other, right? So this is going to be the partition. So I hope you were able to understand what is the basic idea of partitions. Now, there are multiple applications for this as well, right? It is basically about classifying objects on different types. So when you come into future, or when you're solving problems related to coding, you'll figure out that there are some applications to it, right? So I hope you were able to understand it. Moving on, let's try to I'll be giving a bunch of questions for you guys to solve. Since this is not a very tough topic, I'll just leave these questions to you and put the answers in the description.